Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer the questions on the Pure Mathematics P4 International A-Level Edexcel June 2023 exam. And these questions, I'm going to answer them question by question on separate videos. So this first video will be question 1, and I'll make separate videos for each of the other questions, sometimes even parts of each question, depending on the topic, because I will also save these videos not only in a playlist which will contain all the questions in this particular paper, but also all the questions related to the particular topic the question is related to. That makes it easier for students to revise, and if they want to look at things topic wise or paper wise, it makes it a bit easier for them. The second thing I'd like to mention is that I'm not just going to write down exactly what the mark scheme says and not explain anything. I'm going to try to explain the topic. Sometimes I go into some detail depending on the topic. Sometimes I have a particular question in my mind that a student has asked me, and I want to make something clear for that student or students in general. Sometimes I talk about common mistakes that people make in order to help you learn, because I'm a teacher and I like to teach, not just to read off the mark scheme. So bear with me. If you're here looking just to see what the answers are, then go to the mark scheme. All right. But if you're here to learn and to try and find out some tips of how to do the exam and how to answer certain questions and to find out what's behind some of the concepts, then you're welcome to continue watching. All right. So now let's get on with the first question. The first question says, find the first 4 terms of the binomial expansion in ascending powers of x of this bracket, this binomial, a quarter minus a half x all to the power of negative 3 over 2, where the modulus of x has to be less than a half. Okay, now, giving each term in simplest form. Now, this part here doesn't really affect us in this question at all, okay, at this moment in terms of what we have to do in the question, right? But sometimes we are kind of asked to give some explanation or have some understanding of why this is there. We can explain that later. Okay, but first, let's just deal with the question at hand. So we're used to, in P2 AS Maths, having binomial expansion where the power was always a positive integer. Okay. In P4, we have these binomial expansions which deal with either negative integers or with fractional powers. Okay, so the fractional power, like here, or negative integers. Those questions, we cannot use the NCR button that we're so used to from P2. In P2, it's very easy to use the NCR button and answer the question quite quickly, especially when it's in this type of form. But when you have this power not being a positive integer, if it's either a negative integer or a fractional power, then we cannot use the NCR method, and we have to use a particular format, a formula, which after a bit of practice you should be able to get to know quite easily, and it's also written in the formula book. So I'm going to just paste it, have it ready in my clipboard. So here we have, this is just clipped straight out of the P4 formula sheet. So it says 1 plus x to the power of n equals 1 plus nx plus n times n minus 1 over 1 times 2 x squared plus ... means follow that same pattern, and you keep going. So it's n. The next one will be n times n minus 1 times n minus 2 over 1 times 2 times 3, which is basically 3 factorial, times x cubed, and so on. Okay, so this is the formula that we're going to use to expand this. Now, the thing about this formula, it's very important for us to realize, is that in this position here, there should be just a 1. Okay, so the way this is at the moment, we cannot apply the formula to this until this says a 1 here. So we have to manipulate this algebraically until we're left with a 1 in that place. Okay, so what I'm going to do is I'm going to show you how to rewrite this such that it's got something with a 1 inside this space. So we're going to take this 1 quarter minus a half x to a power of negative 3 over 2. And the first thing we're going to do is we're going to make there be a 1 here. So I'm going to write this big bracket because of this power here. And I'm going to take out a quarter from this bracket. So basically what I'm doing is I'm dividing this term by a quarter. So I'm going to get 1, which is what I want. So a quarter times 1 is a quarter. And therefore I have to also take this term, which is a negative term, and divide this by a quarter. So what is a half divided by a quarter? Well, a half divided by a quarter is the same as a half times 4 over 1, which gives you 2. So this is going to be 2x. And all of this is raised to the power of negative 3 over 2. Okay, so now if you want to just make sure that this is exactly the same as that, if you multiply a quarter by 1, you get a quarter, and a quarter by negative 2, you get minus 2 over 4, which is minus a half. So minus a half x. So these two are equal. There's no doubt about that. So now I have a 1 here, but I've got this like strange kind of, bracket here, and then I've got this other term inside. How do I sort that out? Well, what I can do is I can use one of the laws of indices. If I know I have a times b all raised to the power inside the bracket, I'm not talking about a times b to the power of n. I'm talking about when they're both in the bracket, both raised to the power of n. I can rewrite this as a to the power of n times b to the power of n. Okay, I can rewrite it like this. So what I can do here is I can say this is equal to a quarter to the power of negative 3 over 2 times 1 minus 2x to the power of negative 3 over 2. And how do I write down what the value of this is? Well, we know that one of the rules of indices is if you have something written to a negative power, then you can write the reciprocal of that thing to a positive power, to the same power but positive. So what I can do here is I can write that 1 quarter as 4 over 1, which is 4. So that's going to be 4, okay, to the power of positive 3 over 2. And that's going to be multiplied by this bracket 1 minus 2x to the power of negative 3 over 2. And what is 4 to the power of 3 over 2, sorry? Okay, now 4 to the power of 3 over 2 is the same as, if we think about it, what we learned in our rules of indices, if I have a to the power of m over n, this is the same as if it's a fractional power, the denominator is the root, the numerator is the power. So this is the nth root of a to the power of m. So this is the square root of 4 to the power of 3. So this is like the square root of 4 to the power of 3 times 1 minus 2x to the power of negative 3 over 2. And the square root of 4 is 2. 2 cubed is 8. So this ends up as being 8 times 1 minus 2x to the power of negative 3 over 2. All right, so I can rewrite this as that. They're the same thing. They're exactly the same. So when I expand this, I should get the same expansion as this, of course, right? But this I can't expand the way it looks because I can only apply this formula when there's a 1 in this place. So now there's a 1 in this place, I can apply this formula to this expression here. So here I have 8 times 1 minus 2x to the power of negative 3 over 2. And so when I use this expansion, now I'm going to have 8 times, and I'll put this big square bracket because I have to multiply the expansion of this by 8. I'm going to have 1 plus nx. So 1 is going to be there plus n. Now what is n? N is the power, whatever power is over here. So that's minus 3 over 2 times nx. So it's that power which is times x. What's x? X is whatever term is in this position here. So this term here is our x. Okay, this term here is the x in our formula. So I can see that this term here, this x here, is basically this. Okay, those are the same. All right, so what I'm going to do is I'll put here negative 2x. So this is 1 plus nx. And we're asked to give the first 4 terms. All right, right now we have the first 2 terms. This is going to be 1 plus this term. They'll just be multiplied by the 8, but there will be 2 terms. We need another 2 terms. So let's continue on and you carry on with the pattern. So it's going to be n, which is our negative 3 over 2, times n minus 1. So you're going to have negative 3 over 2 take away 1, which is the same as take away 2 over 2. So minus 3 minus 2 is minus 5. So you're going to have minus 5 over 2 times, or divided by 1 plus 2, which is basically, that's 2 factorial, which is 2 times 1. So 1 times 2 here, times this term, which is minus 2x, but we have to square it now. So it's minus 2x all squared. Don't forget the minus sign is also inside this bracket. Then we're going to have, that's now 1, 2, 3 terms. We're going to have the fourth term, which is going to be following the same pattern. You have minus 3 over 2 times minus 5 over 2 times minus 7 over 2 times minus 2x all squared. Oh, sorry, all cubed this time. Okay, and that's going to be over 3 factorial, which is 3 times 2 times 1. Okay, so I should have started this a bit on that side, but hopefully that's clear. All right, so now we have got to as far as we need. I'm just going to put dot, dot, dot and the bracket. So I'm not really supposed to write there, but you understand what's going on. Okay, so now we have 8. Now I'm not going to start multiplying by 8 until I have just simplified some of these first. All right, so this is 1. Then I'm going to have minus 3 over 2 times minus 2x. So minus times minus is positive. So this term will definitely be positive. So I can ignore the minus signs now. The 2's will cancel out when I multiply these, because this is, remember, it's like 3 over 2 times minus 2x over 1. The 2's cancel out, leaving you with just 3x. That's going to be plus 3x. And this term here, what I'm going to do, I've got minus times minus, which is positive, and I have minus 2x all squared, which is also positive. So this term will also be positive. So I can ignore the minus signs now. And I've got here 3 times 5, which is 15. And I have 2 times 2 times 2. These will all be the denominator. So that's 15 over 8. And I'm going to square this bracket now. As we said, that's going to become positive 4x squared. Minus 2x all squared is 4x squared. Okay, becomes positive because you're squaring a negative number. And then for the last term here, you have, let's see if it's going to be positive, negative. You have negative times negative times negative, which is negative. And then you have a negative term cubed, which is going to become negative. So you have a negative times a negative, which is a positive. So this term is also going to be positive, and I can ignore the minus signs in here. Now I've got here on the numerator a 3, which I can cancel with this 3 down here. And I think that's all we can cancel. We have 5 times 7, which is 35, over 2 times 2 times 2 times 2, which is 16. And this is multiplied by, now remember, we've already considered the negative sign, so we don't have to worry about that. We considered that was negative times negatives, that became positive. So it's just 2x all cubed, which is 8x cubed. Okay, and I'm going to close the bracket, plus dot, dot, dot. Okay, so now all we're left to do is to simplify this. So I'm going to multiply each term by 8. So 8 times 1 is 8. 8 times 3x is 24x. 8 times 15 over 8 times 4x squared. Well, the 8's cancel out, leaving with 15 times 4, which is plus 60x squared. And when I cancel this out, this is going to be the 8 and the 16 cancel out, leaving you with 2. And the 2 and the 8 cancel out, leaving you with 4. 35 times 4, that's 70 times 2, which is 140. So you end up with 140x cubed, and that is our answer here. That is the expansion we're looking for. 8 plus 24x plus 60x squared plus 140x cubed. Okay, so that concludes part A of this question. All right, so it's slightly involved, but it's, if you just keep your head straight and make sure you write things neatly, unlike I did over there. I should have really started this on its own line from here, made it neater. Okay, but in the end, you get to the correct answer if you just make sure you don't make any silly mistakes with your cancelling. Right, so what I would suggest you do is, like, maybe put this in your calculator. All right, 35 over 16 times 8, and then multiply that by 8, and so on. Anyway, then it says, given that a quarter minus a half x to the power of n multiplied by a quarter minus a half x to the power of negative 3 over 2 is equal to a quarter minus a half x to the power of a half, write down the value of n. Now, when the question says write down, and it's a very short, only 1 mark, okay, write down, that means there's not much work involved, right? You can see almost what the answer is going to be. And the answer to this is based on the fact that we know that we have a term raised to a power. You can think of this as like one term raised to a power. And this is another term multiplied by that same term, and they're the same. raised to another power, and that gives you an answer which is that same base basically to another power. So we know from our understanding of indices that something to the power of m times the same thing to the power of n, the same base, is the same as a to the power of m plus n. We can add the powers if the bases are the same. So here the bases are the same, and this answer with that same base, therefore we can say that this power plus that power is equal to that power. So we can say n plus minus 3 over 2 must give us a half. So therefore we can say n is equal to a half plus 3 over 2, which is 4 over 2. So therefore we can say n is equal to 2. Okay. If you didn't show any work in it, you just worked out in your head, that's perfectly fine. It says write down. They just want to see n equals 2. That's it. Okay. So there's your answer to part B of this question. Pretty simple, part B. Now for part C. All right. So here we've got the answer to part B. That should be a power of 2 now. Here we have the answer to part A. Okay. As we found, it says hence or otherwise. So hence or otherwise, find the first three terms of the binomial expansion in ascending powers of x of. Now we got the same thing as before, okay, as we had before, except it's raised to a different power. So of course your answer is not going to be the same. Now there are two ways we can answer this question. There's hence and there's otherwise. So they gave you a choice. Now sometimes the question will just say hence, meaning using what you just did in parts A and B. So using these two, we have to answer the question. So sometimes they do force you to use a particular way based on what you did in previous parts of the question. So you have to be aware of these statements. Normally, the hence way is the easier way. But I feel here that the hence way is not really that much easier than the otherwise way. Okay, I think the otherwise way might be simpler. But I'm going to show you both ways. Okay, I'm going to show you both ways because sometimes the question will just say hence. So you should know how to deal with that question if it says hence without the otherwise. Okay, so let's just go through hence. Okay, we're going to show the hence way, meaning using parts that we did earlier in the question. All right, so that's why I have this written down here. So in the hence way, okay, we've got to find the expansion of this a quarter minus a half x to the power of a half. And we can see that what we're trying to find is equal to what we found earlier, that's what we answered here, times a quarter minus a half x to the power of 2. So I can say, I'll write it down here so I don't run out of space, a quarter minus a half x to the power of a half is the same as a quarter minus a half x squared multiplied by this, which I can rewrite as 8 plus 24x plus 60x squared plus 140x cubed plus ... All right, so we have to find the first three terms of the binomial expansion of this. Okay, and the first three terms are going to be a constant, and then an x term, and then an x squared term. So that's all we need from this. So first of all, what I'm going to do is I'm going to expand this squared bracket. Now, when you expand a squared bracket, you square the first term. That's going to give us 1 over 16. Then you multiply these terms together and then double your answer. So you're going to have basically 2 times a quarter times minus a half x. So the 2's will cancel, so you're left with minus a quarter x. So it's 1 over 16 minus a quarter x, and then the last term squared. So the minus is going to become a plus, and will be the square of a quarter of a half is a quarter. So you have plus a quarter x squared. So that's the expansion of this bracket, and I have to multiply it by this. And I don't need to have all the terms. I have to only have up to the x squared term. So it really doesn't even matter. I don't even have to write the x cubed term here. And when I expand this, I can see I'm going to have a constant. I'm going to have an x term. I'm going to have x squared terms. That's as far as I stop. I have to stop at x squared. So when we expand this, anything that multiplies to give you something that's more than x squared, I'm going to ignore it. All right. So let's start expanding 1 over 16 times 8. That's 1/2. Okay, 8 over 16. And then 1 over 16 times 24x. Okay, so that's plus 24 of, I'll write it unsimplified first and then I'll simplify it. 24x over 16. And then 1 over 16 times 60x squared, so that's going to be plus 60 over 16 x squared. Now 1 over 16 times 140x cubed I don't need, because that's going to be, the first three terms are going to be a number, an x squared term. Now the mistake people do or make in this question is they will stop there. They don't think about what other x terms and what other x squared terms might be in the expansion. So you have to think about what happens when I multiply minus a quarter x now by this. Of course, it's going to give us an x term. You're going to have, that's going to be minus, so I can change this to a minus. That's going to be minus, and a quarter x times 8 is going to be 2, minus 2x. Okay, so it's going to be 8 over 4, going to give us 2. Then you have minus a quarter x times plus 24, that's minus a quarter of 24 is 6, that's going to be 6x. Gives us a whole number, so I've just multiplied it. X squared. Sorry, x squared. Why? Because this is minus a quarter x times 24x, x times x is x squared. So the minus a quarter x times 60x squared I don't need, that's going to be x cubed. I don't need x cubed, I just need a constant x and x squared term. So I'm going to ignore the next term, which is a quarter x cubed, and the other next one would be x to the power 4. I don't need them, right? No need wasting our time. So now I'm going to look at the last term here, which is a quarter x squared, and see if that gives us something which is either a constant or an x term or an x squared term. Well, of course, a quarter x squared times 8 is going to give me plus 2x squared. And if I continue, I'm going to get x cubed and x to the power 4 and x to the power 5. I don't need those. So I'm going to stop there. So now I've gathered together only the terms in constant, x and x squared, because we're only looking for the first three terms in ascending powers of x. Ascending means increasing powers. Okay, so now I can just simplify this. With the constant, it's just a half. There's no like terms. Now you have 24x over 16, and you have minus 2x. Okay, so 24x over 16 and minus 2x, no other x terms. Okay, so this is going to be, you could say 24x over 16 minus, and this is going to be 32x over 16, just to make it a bit easier to simplify. And you have plus 60x squared over 16, and you're going to have another 2x squared term. So you're going to have minus 6x squared and plus 2x squared. Well, that's going to, I can simplify those easy. That's going to be minus 4x squared. That's going to be minus 4x squared. Okay, so let's simplify this. This is a half. You have 24 minus 32, which is minus 8 over 16x. And you have 60 over 16 minus, and that's going to be 16. No, that's 64 over 16. So you have plus 60 over 16 minus 64 over 16. That gives you 4. And they're both x squared terms. So you end up with a half, and that's going to give you minus a half x. And here you're going to have minus, that's going to be 4 over 16, which is a quarter x squared. Because when you add 60 and minus 64 gives you minus 4. Minus 4 over 16 is minus a quarter. And there's our expansion. A half minus a half x minus a quarter x squared. Okay, so there we have the answer to question number C. And we have used the method that says hence. Okay, we have used a method that says hence. All right. That's, as I said, the reason why I'm going through this for both ways for you is because sometimes they do only say hence. And in which case you will lose marks if you just do it the other way. Right. So hence means using your answers. But because it says or otherwise, then we are also free to expand this in the way that we expanded part A. But we have to just realize that the numbers will be different now. So we'll do the same thing in the beginning. We'll take out the quarter. You'll have 1 and you'll have minus 2x. But this time it will be all to the power of a half. So you have a quarter to the power of a half, which is a half. And you have 1 minus 2x to the power of a half. So you end up getting a half times 1 minus 2x to the power of a half. And then we need only the first three terms of this. So if we do the expansion, we're going to have a half times, we have 1 plus nx. So this time the n is a half. So it's a half times minus 2x plus n times n minus 1. So you have a half times n minus 1. So it's minus a half. A half minus 1 is minus a half. Divided by 2 factorial, which is 2 times 1, multiplied by minus 2x, all squared. And we don't need to go any further than that. Okay, we don't need to go any further than that because we only want the first 3 terms. So that'll be the first term, that'll be the second term, that'll be the third term. So that will now give us our answer. If we just simplify, so we have a half times, we have 1, that's going to be minus x. And you're going to have here negative 1 over 8 times 4x squared. Minus 2x all squared is 4x squared. Okay, so if you now expand this, you have a half minus a half x, and this is going to be 4 over 8, which is a half times a half, so it's going to be minus a quarter x squared. And that is exactly the same answer, a half minus a half x minus a quarter x squared, as we got. All right, now I personally think in this particular case, the otherwise method actually is way quicker, right? You probably realize that from us doing it, okay? And there's not that much thinking involved in it, okay? And it's just quicker. So I would personally answer this question in this way in the exam, unless it just said hence. If it said hence, then you have to use B. But the mark scheme shows, of course, shows this way in the main working. But then it shows in the footnotes this method as well, and you know, both of them get the full marks, right? So personally myself, I find, even though normally the hence way is quicker, in this case I think the otherwise way is quicker, but it's important for us to have an understanding of how to use both ways, especially in case the question just said hence, which is very often the case. Okay, so that concludes this question number 1 from the June 2023 International A-Level Edexcel Pure Mathematics P4 paper from Edexcel. Other questions from this paper will be found in the playlist that will appear in this section over here once the video ends. You'll see another section here which shows all the questions from P4 on binomial expansion that I have collected together. And you can subscribe to my channel by clicking on this link if you haven't already done so. And if you would like to watch a video which tells you how to use my channel, no matter whether you're doing IGCSEs or Edexcel or Cambridge or whatever A-level you're taking, you can navigate the channel very easily by using this link over here. It shows you how to use the channel. Thank you for watching and see you soon.